Okay, we're going to pick up right where we left off with these AP questions, multiple choice questions from the 2012 exam. This one, I believe we've done. So let's see, but it's tricky, right? So let's see if you can figure out how to do it correctly. Go ahead, hit pause. Okay. Gonna go to the answer. All right, so we get C. I haven't done it out as much as I did on the other one, but that's just the nature of how I'm doing this. But if you let u equal e or if u is root x, right? Then du is 1 over 2 root x. So if I multiply by 2, then I get du is 1 over root x. So that's this root x, right? And then I need to have the 2 out front to balance everything out, right? So at that point, I'm down to A, B, or C, right? And then what I need to do next is convert the bounds, right? Because these are x values, I need to switch over to u values. How do I do that? I use u equals root x. So I plug in 4 for x here. Root of that is 2. Plug in 1, I get 1. So the bounds change 1 to 2. Okay, we are going to go straight to 15. Gotta zoom out a little bit. This one probably looks familiar. Let's see if you can remember how to do this type of problem. And we want to figure out which one of these is smallest in the middle and the biggest. So order them from smallest to biggest. H of 6, H prime of 6, and H double prime. All right, flip into our answer. Go down a little bit. All right. Remember, h of 6 is I'm just going to plug in 6 for this x value. That is this right here. That is a negative number, right? And then I'm going to use second FTC. H prime is f, right? That's my second FTC. That taking the derivative of this integral cancels with the integral. So h prime of 6, well, look, f is 0 there, right? So h prime is 0. And then h double prime, well, I just take the derivative of this line. That gives me the f turns to an f prime. Well, f prime is the slope of this thing here, and that's positive. So I get positive. So I got a negative, and then a 0, and then a positive. So it's nice, it's really convenient. These are already in ascending order. So I got to find them. This is less than that is less than that at 6. And that is A. Next one, we're going to go to 17, I think. Yep. All right, so zoom out. Man. All right, so let me actually zoom in a little bit so you can read the question, and then I'll zoom out so you can see all the answer options. So the figure above shows the graph of f. If f is the integral starting from 2 going to x of g of t, so this is the integral from 2 to x of g of t, which of the following could be y equals g of x? Um, we just did a second FTC problem. I would suggest trying to do that here as well so you can figure out what G is. It's a confusing one, but once you see it, I hope it makes sense. Going to the answer. All right, so it's just A. If this is F, then what is G? This should be a line. This is an equal sign right here. F prime is G, right? So G is just going to be the derivative of this graph, right? They don't give me any information about this other than I can see that it has a positive slope, right? So, and it looks constant, right? It looks like this is a line, right? So what's the slope of a straight line that's going up? It's a positive number. So I take A. Um, this one's weird and confusing and almost like you might not know where to go at all when you see it at first. But hopefully you see it now with a little bit of help. What number is this? 17. We're going to go to 18. All right. Oh, there's 18. Oop, boom. All right, so uh, calculate that limit. There are tons of ways to do it. I think Hopital's rule is the easiest way. The one thing that I will point out that is a common error is that if you're deriving with respect to h here, which you would do with Hopital's rule, there are no h's in this. So this here, minus ln of 4, is a constant. So hit pause, go ahead and do it. All right, so your answer for this one is B. Let me go through why. Like I said, this right here, the derivative, if I'm going to use Hopital's rule, remember it's the derivative of the top divided by the derivative of the bottom. This right here, it's a constant. So when I derive it with respect to h, and you could always make all these x's. Some of you guys like really don't like it when it's anything other than x. So you could write limit as x goes to 0, blah, 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 change these to x's. But that thing does not change. And then right here, I just wrote the derivative of ln of. It's ln of x derives to 1 over x. So ln of derives to 1 over of, right? What is 1 over of for this? It's 1 over 4 plus h minus 0. And then what's the derivative of the bottom? It's 1. And then I can plug 0 in. So I plug 0 in, and I get 1 over 4. So the answer is B. Next question, we're going to skip a couple. Go to 21. All right, zoom ahead a little bit. All right, so y equals 5 is a horizontal asymptote to the graph of which of the following functions? This kind of is almost a little bit of a throwback to Algebra 2 and pre-calc. Which one of these would have a horizontal asymptote of 5, positive 5? The answer here is E. Um, uh, well, this doesn't have a horizontal asymptote, so this A. I'm gonna kind of walk by it for a moment. Y equals 5x. No, that just has a slope of 5, right? That would be y prime. This is y. This is a, it doesn't have a horizontal asymptote at all. This one would have a horizontal asymptote of 0 because as the bottom gets big, it goes to 0. Here, this is almost there. Remember, when I've got these rational functions and they tie in terms of like x and x, right? With the power of the x's, we divide the coefficients. So I divide 5 by -1, but that gives me -5, and that is not 5. Come over here, 20x squared in the top minus x, 1 plus 4x squared in the bottom. X squared is the biggest term for each of these, so that I do the same process that I just talked about with D. I could take the 20 divided by the 4, and that gives me 5, which means that this thing here, E, does have a horizontal asymptote of 5. So the answer is E. Let's pop to the next one. I'm going to go to 24. Skipping around a little bit just because of the nature of how we're doing this. Okay, so this one. All right, so they give me G is this thing where K is a constant. And then they want me to figure out the value of K that gives a critical point at x equals 2/3. So just a reminder, a critical point is when the derivative is 0 or undefined. So you're going to take the derivative and then set it equal to 0 and solve for K. All right, let's flip over to the solution, go through a couple here. All right, so I got A, -3. How do I do that? Well, G prime, I use some product rule here and some chain rule. My product rule is derivative of the first, that's 2x, is the derivative of x squared times e to the kx plus the chain rule here on this second, this e to the, remember the derivative of e to the is e to the but I need to do my chain, which pops the k out front. So I get plus k times x squared times e to the. From there, I can factor the e to the kx out. I can actually factor in x e to the kx out because both of them have those x terms. So x e to the kx, right? And then, remember, I want to have a critical point at 2/3, right? So I'm going to set this equal to 0, right? I do have a critical point at 0, but that I can't, doesn't help me with this question, right? So I set this equal to 0, right? 2 plus kx equals 0, right? And I get x equals negative 2 over k. So the question is, what k value makes that 2/3? Well, negative 3, because it'll give me my 2/3 and then cancel with that negative and make it positive. So the answer is A. We're going to do 25. All right. Separation of variables. Which of the following is a solution to the differential equation dy dx equals 2 sine x with the initial condition y of pi is 1? We might have done this one at some point. It's been a while. Here comes the answer. I got E. I integrate this thing. I get negative because of the derivative of cosine is negative. And this guy's positive. So I got to double negative it. I get negative cosine x plus a constant. And then I plug in pi for x to solve for my constant. And then cosine of pi, there's not much work shown here, but cosine of pi, if you were to draw a unit circle, y-axis, x-axis, we would be over here on the left. X value is -1. So this is -1, which gives me a +2. Move it over to the left side, c is -1. So it would be this with this value at -1, so I get E. One more. We're going to do 27, and then I'll be done. So let me skip that one. 27. Okay, so this is a second derivative problem, like implicit differentiation one. We've definitely done this in BC, and if we did do it in AB, it was really quick. So hit pause, give it a shot, and then I will go through an explanation of the easy way to do it. There are some hard ways to do this. Oh, I should also say, people always have trouble. What's this mean? This is a second derivative. All right, let's go over to 27 on here. Okay, the answer is A. Here's why. Okay, so this is the easy way to do this one. Easier way to do this one. We we're looking for the second derivative. This would be like the first line in, or like one of the lines in trying to solve for the first derivative. So what I can do is look at this line right here. I'll explain that thing. If I take the derivative of this line right here, I get an equation right here with the second derivative in it. Look, I got this mess times that thing equals this mess. If I take the derivative of this, it's product rule. So derivative of this times that plus derivative of this times that. This part's derivative is that second derivative. I'm using a shorthand notation here, but it's totally fine. So what's the derivative of this? 1 is the derivative of x. What's the derivative of 2y? 2y prime times y prime. That's derivative of the first times the second. Plus derivative of the second is y double prime times this. I got to speed up because I'm coming close to my time. So this guy gives me a y double prime minus, sorry, equals the derivative of this is -2, or sorry, 2, and then minus y prime. So from here, I get a line that looks really bad. But look, I got x equals 3 and y equals 0. So I can make all these x's, or sorry, this x3 and all of these y's, I guess there's only one of them, this y is 0. That gives me my 3 here, right? From there, I can plug in 3, 0 to this piece up here, right? And then I can solve for dy dx. That gives me my y prime is 2. From there, I can plug in y prime for all of these pieces and solve for this thing. And if you do that, you get an equation that's quick to solve and you get A.